Okay, so like we learned earlier, right?
Yeah.
Our schematics are gonna, our power is gonna come vertically for a ladder diagram, right? So our power is gonna come in, so we can do this, we can do whatever we want, L2, L1.
I don't like that.
You might just flip them.
What'd you say, you don't like that?
No, better switch it back to where it's been.
L1 and L2?
Yes, sir.
Okay.
Doesn't make
Yeah, that kinda messes with my head.
Does it matter?
You already confusing me, just do 2 lines.
L1, L2, okay, or it could be neutral, you want it neutral, we can put it neutral.
How we put
Either
it
way,
neutral?
that's the high voltage section, right?
Yeah.
So we're gonna start with a circuit, right? Let's check this out, right here. We're gonna call this we're gonna call it a C. What would that C be?
Coil.
Coil.
No,
What?
high voltage, we're on high voltage.
Compressor.
That's
Compressor,
Compressor.
compressor,
But right here it says.
Yeah, that's what it's called. Yeah,
Okay.
yeah.
I'll do it this way. C-O-M-P, comp, not Compton, it's
Whoa.
compressor.
Straight out of compressor.
Yeah. Straight out of compressor. Okay, so
Bro.
we got this hooked to our L1 and L2, we need a way to turn it on and off, right?
L2's the load, right?
So you need a switch?
L2 would be the load side, yes.
Low.
Because if
Say
it was
yes.
neutral, it would be over here, and it would be the load
L2 be the
side.
load side?
Yeah.
Thought it would be neutral.
And you said you needed a fuse?
No,
Or
we need
switch.
something to turn it on and off.
Switch.
Because right now, it's
Switch.
running all the time, right?
Switch, yes.
We need a switch. How about a set of contacts?
No, a
Okay.
switch.
We'll put a set of contacts in there, like so. And we'll put, how about we put one over there?
Yeah, might as well.
Ah, we got 2 full contacts. We got that dude right there, right? We'll use that one.
Yeah,
How's that?
okay, now the.
Huh? Okay. Alright, so that's a high voltage load that we've got with 2 switches. Now, when we're looking at schematics, like we looked at here, remember the schematic here?
Yes,
Does that look confusing?
no,
Which one's that one? Oh.
That one?
I already lost that one.
You want one that looks confusing? I'll get you one.
no, no.
So, in order to understand these, the best way that I know to think about all our schematics are just switches and loads. That's all that's in our schematics, switches and loads, okay? Loads go in parallel, switches go in series
Okay,
with the loads, okay? So we know the difference between series and parallel, right?
yes.
So, this switch is in series with that load, right? Okay, so if we put another load on this
It
line,
has to be parallel, no, in the same line?
yeah, we'll do it on the same line.
Loads go.
Check it out,
Parallel?
Check it out.
we'll go right here,
How do you make it parallel? Oh. Right.
so now we got a second load in there, and it's in parallel. So that load is gonna be controlled by that same contactor, right?
Yeah.
Wow.
Same switch.
We'll call this the
Con?
con, sensor.
Condenser.
Condenser. What?
Condenser fan,
CFM?
condenser fan motor, you want a CFM?
Oh, okay.
You wanna call it a CFM, is that what you wanna call it?
I mean, that's what it is.
CFM?
Mm-hmm. Condenser fan motor.
Okay, condenser fan motor, right?
Yes.
So in air conditioning and refrigeration, that condenser fan motor needs to run anytime that compressor's on. Okay,
Makes sense, yeah.
so that's why they hook it the way they do, right?
Yeah.
As soon as that compressor comes on, that condenser fan's gonna take off with it, right?
Mm-hmm.
Okay, we'll do this, we'll do this another way here. So if we take this down a little further, give me a little more power here. And we come across here and then we do this. We'll put another load. Now this load is in series or in parallel with what?
Compressor.
It's all in parallel, right? They're all in parallel. Loads are in parallel. So we call this the
Fan motor.
the BM,
Baby
Lower
mama.
motor.
lower motor. Whoa. Lower motor, there we go. Okay, so we also need a way to turn that on and off, right?
How do we do that?
Well, we put that contactor in there, right?
That makes sense.
Okay, we'll put a contactor in there. Okay, so far we've got some contacts in there, but we haven't identified it, right? So on this contactor here is gonna be a CC. We'll call that a CC.
Contactor coil.
No,
What does that stand for?
Comp coil.
compressor contactor.
Compressor contactor.
Simply calling it. Okay, so on this one, we could identify that as a VR.
Blower relay.
There you go.
Hey.
Man,
Hey, click.
whoa.
The light switch. Top.
It went like
Okay,
this.
so we got a blower relay, blower motor, condenser fan motor, compressor, and compressor contactor, right?
Yeah.
Check it out. Check it out. You ready for this? I'm gonna do this.
It's a coil.
Coil,
Yes,
Pollo,
sir.
a pollo loco.
coil,
Your coil loco?
coil.
Oh, it's a transformer.
Transforms.
Oh, yeah, we'll put a line through that, means it's iron core.
120 volts.
Yeah, well, no, this is 240.
240.
L1, L2.
1L2.
L1, L2, remember?
240 volts. Okay.
And this down here is always gonna be 24 volts, right?
Jeez, no.
Okay, so we got the low voltage here, so check this out. We're gonna put down a thermostat down here.
I'm checking it out.
Jeez.
How
We'll
we
make
do
it a
that?
round thermostat, how's that?
How's that
So
make
all our
sense?
transformers, when we're talking about transformers, check this out.
I'm checking it out.
The secondary part of that transformer,
Yeah.
which is a 24,
Yeah.
or the output side, or whatever you wanna call it, we call it secondary, are always identified as common on this side and red on this side. So common and red is our indicators for our 24 volt side, our low voltage, wiring,
Got
right?
it. Okay.
So
that's how you
check out the
identify
red,
it.
huh?
That's how you identify it. Red is
The
hot.
red,
Hot.
hot. It's right there.
Right.
Check it out, man, stuff's coming together.
Okay, what is C?
Yeah.
Stuff is coming together now.
That's wild.
That's
See,
the
it's
red
common.
right there we're talking about.
Common.
That's it.
So what was the common? Like the C?
The common,
Yeah.
the common's the other side. That's the path for the current to flow.
Hmm.
Just like we have here, we
Yeah.
have to have a complete circuit.
Okay.
So we're gonna use the secondary voltage and we're gonna take it back, everything's gonna come back to common
Oh.
in order to have a complete circuit. We're not done there, we're not there yet. Okay, so we got our red terminal on our thermostat hooked to our red wire, identified, right?
Hot.
Alright, hot.
Okay,
Thermostat.
okay,
H-A-W-T.
so we're gonna take a wire here. We're gonna take a wire out of our thermostat and we'll call that the green wire. Green,
Fan.
you know that's a fan, huh?
Yes, sir.
Okay, so we're gonna put the load or the coil side of that relay, and we're gonna identify it, so we know where it is in the schematic. It's gonna be the VR. Right, see that? VR there,
Oh, B.
VR there. That tells us, because it's indicated the same way, that tells us that this and that is the same component, just like that component right there on the board.
So operate the same as a fan relay coil, pretty much?
Yeah,
Oh, okay.
so it's a blower relay, it's identified as a blower relay. It's a relay, but on schematics, they're gonna identify it with
VR.
or a control relay, or a blower relay, or a FR, fan relay. So depending on who wrote the schematic up, they're gonna identify it. But the important part is, it's identified here and it's identified there. Same
So
identification.
just be read the same way no matter
Yeah.
what.
So, okay, so we're gonna take another wire off of here, and we'll put another little load here, and what load do you think that might be?
Coil,
Coil, okay, what kind of coil?
contractor coil.
Okay, so, if it's a contactor, or if it's not, the CC would be what? What?
Oh, compressor contractor,
Compressor contactor.
contractor.
Ah, it's all
Like
right.
CC? CC.
CC.
We know that when that energizes, it's gonna close those two contacts. We know because of the identifications that were made on this. Because we got a compressor and a condenser fan motor and a blower motor, we're gonna control the blower motor with the blower relay, right?
Yeah.
Which is down here also. When the thermostat makes red and green, inside, it makes that connection, you go from red through the blower relay, energize that, and back to common. What happens when that happens?
Boom.
Magic.
Pow. Closes those contacts, starts that motor.
Yep.
Wow.
See how that,
Yes.
see that how, you gonna see how that happened? Okay, so when you call for cooling on a thermostat, red makes green, and red also makes yellow.
Cool.
Makes three connections in that thermostat. So if we energize the contactor, it's gonna close this contact and this contact. And it's gonna energize and start the compressor and
And the
condenser
fan.
fan motor, see?
It just creates the circuit. That's what
Yeah.
the thermostat does.
Yeah,
It
if the
completes
thermos-
the circuit to where it controls the relays.
Right, the thermostat is basically,
That's a fucking.
the thermostat
That's smart.
is just a switch.
Yeah,
That's all it is, a switch. Remember our schematics are just switches and loads.
yeah.
The thermostat is just a switch. Switch load, switch load. It's simple. It's
Simple, dude.
simple.
Yeah, when you
Okay.
understand it. If you don't understand it, you're looking at just lines and letters.
Are the neurons clicking now? Are they
Yeah.
firing now?
They're rolling.
Okay. All right, so we got that. So this basically is a basic air conditioning schematic. Simple,
I'm
basic,
taking apart my AC when I get home.
yeah. So when you get into bigger units, you're gonna have more stuff in there. You're gonna have more bells and whistles and stuff like that. And so what you might have is, with a bigger unit, you might have a couple of switches in there like this,
Testing all my relays.
right?
I
Like
just
this.
took the thermostat. That's probably what's wrong with mine.
It's gonna look something like this with this, right?
Oh. Hold on, wait, let me get my key.
Which is
Wait, what?
sales switches?
That's the
Sales switch?
tube right there,
It's a
right?
DPTS switch.
Yeah.
Okay,
I'm wrong as hell.
guess again.
Is those right there, right?
Huh?
Yeah.
Close.
Oh, SPST?
High and low pressure.
Yeah, high and low pressure.
Found it right on the schematic handout, right? High and low pressure switch. But it's a commercial unit, you're gonna see that. And even in some of the residential now, you're gonna see high and low pressure switches inside that control circuit. So if something happens, if it loses refrigerant, if it got a leak, the low pressure switch is gonna open up. And it's not gonna allow that compressor to, start.
That's.
Okay, and on the other side too, the high pressure, if the condenser fan motor burns out, head pressure's gonna go up because it has no cooling now. So that refrigerant is hot and the head pressure goes up, it's gonna trip the high pressure. Open up, kill power to the contactor coil, stop that compressor for safety's sake, right? They're both gonna be used as safeties in this application. You don't want that compressor running without refrigerant. It'll burn up, okay? You don't want to run that compressor under high head pressure too. It'll burn up, okay? Simple?
That is
Sure.
I ain't getting none of that. Look,
No?
Can I take a picture of that real quick?
it's right here, bro.
I just wanna take a picture of that
It's
one.
on, yeah, it's right here.
But I wanna take a picture of that one.
Okay, well, hurry up, 'cause I'm racing it.
Sweet.
Got it? Ready? Got it?
It's good, yeah.
Got it?
Got it. I like that one.
Look at it again.
Would
Oh,
draw
you like that one?
Would draw it on my wall when I get
Oh,
home.
Again, if we're talking about loads and switches, let me show you another one. Another one. If we're talking loads and switches, let's do this again,
man.
right?
Got it.
Bye.
Bye.
Okay. We got L1, L2. Right? Okay. And we got pretty much the same thing, almost. So we got this dude here going on, and that's the compressor.
Press.
You need to switch.
It needs a switch. Okay, we'll put a switch in there, and we'll call that a
CC.
CC. How's that? We'll put two switches in there, how's that?
Does that one have a fan too, or no?
The C, this one,
Just
no,
put a fan relay cord.
no, this doesn't have a fan. This one is water cooled.
Oh.
Okay.
Water cooled. Okay, it does have a blower though. And this is a big one because we're gonna use a starter to start the blower, and we're also gonna use a starter to start the compressor. So these are starters, but we still label them as, contactors. So we'll call this a blower contactor and a blower contactor.
So how do
Compressor
we know,
contactor, blower
how do we
contactor.
know if it's a switch or a, starter?
You don't unless you're there, you gotta look at it.
Oh, okay.
It's a switch, basically it's a switch. It could say on there, starter. This particular one is a built-up system, which meant it was, the one I have in mind, it was built up, so it wasn't manufactured at a factory. It was actually built when the building was built. So they designed it as a built-up system, okay? Okay, for this particular one, we have got, let's just say, we're gonna put a transformer in there. Alright, we got a transformer down there. It wasn't this, but I'm gonna make it this. For the sake of,
So are the starters on the low voltage side? Like where the thermostat would have been?
yeah,
Or does this one have a thermostat as well?
We haven't got there yet.
yeah, I haven't got there yet.
Oh, I'm sorry, I'm just thinking, my brain is just rolling.
Hey, you're ready, man.
Yeah, he's jumping the
What's
gun.
the BC
Okay.
stand for?
So, on this one, because we're talking about a built-up
Lower
system,
contactor.
this one could be, what do we got up here, voltage?
Yeah,
240.
240 and then.
You want 240, huh? Okay,
Yeah.
we'll make it 240.
And then 24.
We went down here?
24.
48.
No, how about 110?
I thought the bottom has to be 24 the
No,
whole
it
time.
doesn't have to be, it's
48
control.
volts.
It's control, the control can be
48
Man,
volts.
I'm getting confused.
110.
Okay.
We're gonna make it 110 because we're pulling in contact, we're pulling in big starters.
Yeah.
Oh.
So we don't want the 24 volts, it's gonna interfere with pulling that big old contactor in. So we want a substantial amount of,
More than enough.
power there to pull in that coil.
Better to have more than less.
So what happens if it has 24 volts?
It's
Blow
not
it
enough.
This won't, probably won't work as much, huh?
Yeah, and we could continue on with this, if we needed another control circuit, we could put another transformer in there and bring it down to 24 if we want.
If we want.
Yeah, but see, because it's a built-up system, we're gonna, we're gonna be doing this.
Okay.
Okay.
So, I've seen where there's a couple of different transformers in package units, commercial units, where they go from 480 volts
Mm-hmm.
down to 240 volts, and then they go from 240 volts down to 24 volts. So there's all kinds of different voltages in there. So, that's confusing.
Not really. We understand
Okay,
the
so,
layout.
on here, what we're gonna do is, we got a high voltage thermostat right here,
Yeah.
that's gonna be looking like this.
Yeah.
Kinda looking about like that, right?
Uh-huh.
I'm gonna make this little thermostat here, right? I'm gonna dress it up a little bit, so it looks like it's something there, right? See that?
Yep.
Yeah.
Okay, so
This thermostat.
that's gonna operate the compressor.
Yeah, that's the thermostat.
So we're gonna call this the CC,
CC?
it's really a starter.
CC is compressor
Could be,
contactor?
Compressor
Compressor
contactor.
contactor?
Yeah,
Pressure coil?
No.
Compressor
that's a coil,
contactor.
that's a
And-
coil. This happens to be 110 volts.
The blower, you didn't label the blower.
Label the blower.
Label the blower, please.
Yeah, I don't know which one's the blow. Oh, that one's the blow.
Yes, sir.
Okay, blower motor,
Thank you,
right?
Thank you.
Yeah.
Okay, so for this, we're gonna pull power off of this, and then we're gonna have
Blower contactor?
we're gonna have a switch in there. Check it out,
Check,
Wait, the switch.
check it out. We're gonna
Type
put a
of switch.
switch in there,
Yeah.
because everything's operating off of this thermostat.
So would that switch be a
Yeah.
fuse?
What?
The switch, would you use a fuse in that situation?
No. Switch will be up here, somewhere. You wanna put a switch in there?
Well, cause you said you're adding one, like.
I'm adding one.
You're not adding another,
I'm adding another load to the control side,
Yeah.
right? So we're gonna call this the BC. And that's gonna control these. Now,
That's
for
what I said,
that
BC.
BC to turn on, we're gonna put a hand switch on it. Just a switch to turn it on. We're just gonna turn it on. We're gonna turn on that blower.
got it.
And then the compressor's gonna cycle on the thermostat. See that?
Yep.
So the blower's gonna run, it's an office, let's say, the equipment's up in the loft, the office is downstairs, warehouse, it's not air conditioned, but, you know, in the offices there are air conditioning. Here is the, on this too, we can also have some overloads, so we'll put some overloads in there. How's that? We'll put how about we put 2 overloads in there? 2 overloads, right? We have a high and low pressure switch, right? Right, and then we have a high temperature cutout maybe, like this, that's normally closed. Okay, so if something gets too hot, it's gonna kill that circuit, right?
Turn it off.
Yeah.
Okay, so, like I said before, the switches are all gonna be in series with the load. The loads are gonna be in parallel with each other, right?
Can you do the dots? Can you do the?
No,
So you totally
No.
Oh.
I'm not done yet. Okay, so, we got that. Okay, so here is what we're also gonna do. Check this out.
Check this out. I'm
Are you checking it out?
I'm checking it.
We can't put switches in parallel.
We can't,
Can.
we can't.
You
So
probably
we'll put a
switches
switch in
anywhere,
here.
huh? You can probably literally put them anywhere, huh? Kind of, just make sure it's by the way.
We're gonna put a little switch in here like this, right? Right like that.
So when you turn that on, it's gonna turn on the.
Okay, so really, this thermostat is located somewhere down in the office, right?
Yeah.
It's gonna sense temperature of what's air in the office, right? This switch here is located at the equipment.
What the?
What the?
No, it makes sense.
Huh.
The thermostat is located.
Cause if it's not calling and you're up there servicing this thing, instead of running down there and setting that thermostat,
Turn the switch on.
you just turn the switch on,
Yeah,
brings on the compressor. Bypasses the thermostat, and then you can do your maintenance, check it out, and everything. So that's what a parallel switch would do. You guys are familiar with parallel switches
yes.
See, senor.
in your house, right?
See, senor.
Wait a minute, what? In your house?
See, senor.
Wait, what's a parallel switch in our house?
Wait, what?
That's like when you go like in your hallway where they have, right?
What
When
would
you have two
bypass the
switches on the
thermostat?
same.
That's
little
not,
opposite
we're not
side?
talking about thermostat, I'm talking about switches in your house.
Oh,
That's like in the hallway, right? When you have two different
Yeah.
switches that turn on the same way.
Those are parallel switches.
Oh,
They're
okay.
3-way switches is what they're called.
Mm.
And you can turn it on either side of the hallway or upstairs and downstairs, you know? So
Yeah.
that's another use for a parallel switch like this, right? So
Yeah.
switches can be put in parallel.
So you
And
can
they
put one
also
up
be
there if
put
you
in-
wanted to? Put another switch on the top?
It's just adding another switch
Yeah,
to
the
the
parallel.
circuit.
What? In parallel, with what?
Parallel switches, put another parallel switch up there. You can put it anywhere, right?
He's running the.
Kind of?
No.
Parallel switches.
No, only certain places you can put them, so you can't put them just anywhere. Okay?
The control comes from the.
This part.
Honestly, get it, bro, it's fucking wild.
What?
It's
Are you
wild,
lost?
I get it.
Are you lost?
Definitely
Okay, so basically, an air conditioning system,
These are just
little bit
like,
different.
Regulated,
Bye.
basically.
by, but it's still the same, it's still showing you what a parallel switch will do. And we'll talk about that, we'll discuss that as we move on, right?
Pretty slow.
Okay? So to give you a
Parallel
little bit
switches
of
have to go to
idea.
the same load, right?
What?
If you did do a parallel switch, it has to go on the same load,
Only on
right?
one level, yeah. Yeah, you could do it, you could also do it with the DC,
Cause that's where you get the power from, right? From
right?
the-
So this switch downstairs, they use when they turn it on, the system, you could have a switch up there in case it wasn't on. So you could also have another switch there,
Damn.
so you could service it, it's a remote, somehow to get that thing started without having to wander around the office and find the thermostat and set it, and then have it reach temperature while you're in the middle of checking it, and it shuts off, and it's like, come on, man. Yeah, that's what I'd say, come on, man. Hey, go down those stairs again. Right?